In this screencast, we're going to talk about how do we name ionic compounds. And we've pretty much already done this. If you watch the first screencast on naming ions, when we name an ionic compound, all we're doing is naming the cation as well as the anion. So let's get started with how we name ionic compounds. There are some rules we need to follow when we are naming cations or ionic compounds. And the first is that we want to name the cation first. The cation is always the first element in the compound, and so that's the first part of the name. You do want to remember that if the cation is a transition metal that has more than one type of charge, like copper or iron, you want to remember the Roman numeral in the name. You want to name the anion last, and you want to remember that you need to change the name ending of the element to IDE. So for example, instead of chlorine, it would be chloride. And then if there is a polyatomic ion present, whether it's the cation or the anion, you want to make sure that you just give it the name that that polyatomic ion has with no changes whatsoever. Let's look at some examples. So for our first example here, we have NaCl. Our first element is Na, and if we were to name that, we would see that the name of Na is simply sodium. So that's the first part of our name for this compound. The second element is Cl. Cl is chlorine, but we want to remember that we changed the name ending to IDE, so it's going to become chloride. So our name for NaCl is sodium chloride. Please pause the video and write this example down in your notes. When you're finished, resume watching the video for some more examples. In this example, we have CaP. Again, we want to name the cation first, and that's Ca, and the name of Ca is calcium. So we're going to write that down as the first part of our name for this compound, and then our last element is P, which is phosphorus. Again, remembering that we changed the name ending for our anions to IDE, this changes from phosphorus to phosphide. So our name for this compound is calcium phosphide. Again, please pause the video and write this example down in your notes. When you're done, resume the video for a few more examples. Okay, so here for our next example, we have Fe2O3. The first thing we want to do is identify our cation and our anion. So our cation is the first element, which is iron, and the anion is the second element, which is oxygen. Now recall that iron can have two different charges. It can either be +2 or +3. So which iron are we dealing with here? When we write the formula, we crisscross the charge. So now we need to take the subscript and take it back over to the cation. So this formula was actually made up of iron 3 ions as well as oxide ions. So when I write the name, I'm going to write iron 3, okay, because my charge is +3 on the iron, and then I write the name for my anion, which is oxide. So Fe2O3 is actually iron 3 oxide. Please pause the video and write this example down in your notes, and then resume your video when you are finished. Okay, so for this example, we have iron and we have oxygen. And when we uncross them, it looks like we have Fe+1 and O-1, since there are no subscripts down here in the formula. But we know, if we look at the periodic table, that oxygen cannot have a charge of -1. Oxygen, in fact, has a charge of -2. So in order to get the charges to cancel out, that means that our iron must have had a charge of +2. And now that we've identified what the charges are on the two ions, we can write the name. Fe+2 is iron 2, and O-2 is oxide. So the name for our compound, FeO, is iron 2 oxide. Please copy this example down in your notes and then resume the video when you have finished. This example shows a compound that has a polyatomic ion in the formula. Our cation is silver and our anion is nitrate. You want to make sure whenever you're looking at naming ionic compounds that you're really careful about what is the cation. The only polyatomic ion that has a positive charge is ammonium, which is NH4 with a +1 charge. Aside from that, all of your cations are going to be a single element. So in this case, we have silver, And again, recall that silver only has one type of charge, so even though silver is a transition metal, we don't write the Roman numeral because it can only be +1. And then we look at our polyatomic ion NO3. If we look on the chart that you made from previous notes about polyatomic ions, you'll see that NO3 has the name nitrate. Because it's a polyatomic ion, we don't change the name of the polyatomic ion at all. So our name for AgNO3 is silver nitrate. Please pause the video and copy this example into your notes, and then resume the video for one more example. This example has it all. We start with Cu, which is our metal, and it's a transition metal, copper. So if we look at what was the charge on that, where do you think the charge comes from? If you said that we look at the subscript on our polyatomic ion as the charge for the metal, you're right. So this is actually copper 2 for our cation. And then for the anion, we have to look at this entire polyatomic ion. C2H3O2 is acetate. If you go back and look at your chart from your previous notes, you should see that. So we have copper 2 acetate as our example for this one. So please pause the video and write this example down in your notes, and then there are some practice problems on the next page for you. Resume the video once you've copied this into your notes. So what I'd like you to do now, below the notes that I've asked you to copy, is just write practice problems, copy down the formulas that are provided here for you, ZnCl2 and so forth, and write the name for each of these 4 compounds. When you have finished, please either turn your handwritten notes into Mrs. Benke or take a picture of your notes and submit them in Schoology. Just as a brief recap, remember when we are naming ionic compounds, we name the cation first. If the cation is in the transition metal section of the periodic table, we want to remember to include the Roman numeral. We name the anion second, changing the name of the element ending to IDE. And if there is a polyatomic ion present anywhere, we simply give it the name of that polyatomic ion. Please note any questions that you have while completing this assignment and bring them up in class with Mrs. Benke.